Welcome everybody. Welcome to our another lecture in red black trees. So in this lecture we will just analyze red black trees implementation and the algorithm in briefly. Okay, so let us go to our book. So actually this lecture will be the continuation of our previous lecture, that where we discuss red black trees and mainly its rotation, and then we discussed that there are two main operations for red black trees. One is insertion, another is deletion. So if you go to our previous lecture slides, so that we have in our slides, we have some intuitive pictures of rotations and insertion and deletion, and the algorithms are over here. So okay, so the steps are over here. So but in this lecture video I will actually go through it with the live program, and instead of describing the pseudocode I will go to the live program and we'll discuss this. Okay, so let's go to our book chapter. So in the book, so the page number is 312 plus 20, then 331. Let me see. Okay, so here you see that, so red black trees, so it has red black trees properties. So please read and understand the properties. Okay, so main properties are that, for instance, a few. Number one is that every node is either in color red or black, nothing else. All nodes will be either red color or black color, nothing else, and the root is always black. Okay, no matter how many elements in a red black tree is, the root is always black, and every leaf or nail node is black. So let us see. So root, this is root, is always black, and every nail, okay, these nodes are always black. So as we know that a red black tree is a binary tree, right? So that means it will have all leaf nodes will have two other nodes, like nil nodes. So all of these are black. So this gray color, let us consider that these are red. Okay, so and then black is black. Okay, and this is red. Okay, so then the next property is that if a node is red, then both of its children are black. So then if a node is red, then both of its children will be black color. Okay, but for its opposite is not true. For instance, if a node is black, then its both nodes need not to be red or black. So it can be see that here. So this is root node, and this second root 41 with value, this is black but this is red, but this is red. So you see that this is black and this is black, and this is red, then this is black and this is black. So don't be misled that. So if a root is black, then don't be misled that both roots needs to be black. It can be black. So here, for instance, this one is black, so its root is black, so then both children are black. Okay, but okay, that's thing. And then it is black, so this children is black, and this side is black, but this side is red. Okay, so what is the next property? So, and for each node, all simple path from the node to the descendant leaves contains the same number of black nodes. That means from each path starting from the node, so if there are how many paths are there. Okay, so here how many paths are there. So here starting from here. Okay, let me get my okay. Okay, so let me explain. So starting from here, so this path, so if we go through this path, so how many black nodes are here? So okay, so 1, 2 and 3 black nodes, and we may consider the nil nodes, or we can skip the nil node. Okay, or similarly we can consider the root node, since it is always black, so we can consider, or we may not consider, but same thing. So let us consider the root node, but do not consider the nil node. So how many blocks? 1, 2 and 3, and then there is another path over here through this route to this route, so 1, 2 and 3, and this route, so 1, 2 and 3, from here to this route, 1, 2 and 3, and from here to this route, 1, 2 and 3, and here to this route is 1, 2 and 3, right? And here, from here to this route is 1, 2 and 3, and similarly here to this route is 1, 2 and 3 black nodes, and here to here 1, 3 black nodes, and here to here there are 3 black nodes. So that means, so this is a red black tree. So it maintains all of the criteria or properties of red black tree. Okay, so these are the properties of red black tree. Okay, now so as we discussed in our previous lecture, that red black tree is needs to understand the knowledge of AVL tree and binary search tree, right? So there are rotations, so we need to understand the rotations. And then in our previous lecture, and then I discussed that there are 4 kinds of rotations, right? So there are 4 kinds of rotation. One is left rotation, that will go right, and another is right rotation, that means that will go left, and another is left right rotation, that will go up and right, and there was another one left rotation, that will go up and left. Okay, so please watch my previous lecture video to understand those. Okay, but since this course is not a data structure course, I should not go in depth implementation of the red black tree, but our goal is to just analyze the red black tree. Okay, and this algorithm. So first algorithm, that first operation is that insertion operation, right? So insertion operation, it is a binary tree, right? So binary tree, so is insertion operation will take log n time in the worst case, so big O notations. And then the difficulty actually to me that in the red black tree is the deletion operation. So delete operation is more complicated. Actually there are multiple cases for delete operations. So let me see. So delete operation, although so delete operation needs, it has, let us see the delete operation algorithms, and then it is complicated, and there are 6 cases, especially there are 6 cases for the siblings: case 1, case 2, case 3, case actually there are 6 cases for deletion operation. Okay, so yeah, you may read the book for more detail, but what I want to do, I want to go through my live program, and then we can analyze our program, and then we can discuss its time complexity. So this is the URL of my program. This is written in Java. So this is the program name is, if you go to my account replit.com/Mokhtar, and then red black tree implementation example 1 Java, this is my program code, and I got it from online, this source. And the time complexity for insertion, deletion, and search, all 3 operations in red black tree is common, and the big O log n. Actually this should be LG. Okay, LGN, that means I can say that log with base 2. Okay, log with base 2. So I can say instead of log, I can say LG. Okay. So here is a node. For instance, for every in binary search tree, like a binary search tree, so every node has its left and right, and then it will have a child. It have a parent, right? So, and then it will have a data. Data can be any type, integer type or any other data type. So it is simple with integer type data. And then there is another enum class, enum color, red and black. So you may implement this color with either in enum or any class, whatever you like. Okay, so this is the red black tree class, and then it has a private static method create red black tree, red black node, and it will just create the node. Okay, create some nodes, and let us see. So then there are variation of nodes. So we know that a node can be a black node, a node can be a red node, and a node can be a null leaf node. Okay, and so there are 3 kinds of node, right? Black node, red node, and null leaf nodes. Okay, and then insertion. This is the insertion operation. Is simple, and so the creating node is after we create node, we need insert operation. So insert operation is pretty simple. Okay, but the difficulty is in its delete operation. So deleting means, so sometimes you need to consider if a node is red, then you can or black, then whatever you have, then you have to consider both color. Okay, color and the node value. Okay, sometimes it needs to shuffle and then change color, and then change node. Okay, so since this course is not a data structure course, so I'm not going to full detail implementation of this red black tree. So but here are my codes. So I like you to go through this code, and if you are interested in, then you can copy this code and in your program, and then you can run it. Okay, for instance, the insertion thing. Oh, one more thing that maybe please give attention, that like in a binary search tree, okay, in a red black tree, there cannot have any duplicate node. Okay, there cannot have any node with same value with an existing node. Okay, there cannot have any duplicate node in red black tree. Okay, so you see that implementation is pretty large. Okay, and then there are 6 types of delete cases. For instance, let us see, there are 6 cases of delete. Case 1, these two. So these are the description. It has the description about the cases. It has the description. The comment line has the description about the cases. So I'm not going to in detail about the different cases, but if you are interested in, you can go to my data structure and algorithm course, and then you can learn this. So case 6. So there is a replace a node method, and then printing a node. Okay, and these are the creation. These are the creation for red blood tree insertion, creating red blood tree, and then some delete operation of red blood tree. Okay, so then if you run this program, then you will see that it runs, and then it true means that means it's deleted. This node is deleted. Okay, so these nodes are deleted. Okay, for instance, if there is no node that if we want to delete it, for instance, we do not have any node with value 11, right? So you do not see any node with value 11. So how about if we want to delete that node with value 11? What will happen? Okay, so we could change the method that it would show no or false. Okay, we keep it as is. Okay, now let me go to our course schedule, and then I may need to change my course schedule again a little bit. Okay, so sorry, this one. Okay, so according to our schedule, so we are in this week data structure, red blood tree insertion and deletion. So then I will not go in depth, so but in our next lecture I will discuss hash table. Okay, and then maybe we will in next week we will complete hash table, and then I will upload quiz 4 and assignment 4 soon. Okay, and then okay, so after 2 weeks we will have another test, right? Test 2 is coming. Okay, after we complete data structure, then we will have a test on data structure. Then what else? Okay, mainly actually in this lecture I wanted to give you this program link. Actually initially I thought that I would discuss the insertion deletion operation in detail, but since this course is not a data structure course, I think it should be out of context for this course. So I'm going to make this lecture short, and then I will see you again in our next lecture, then where we will discuss hash table. Okay, so don't be confused about with the pseudocode, so please go, you can go into the actual program code. Okay, so I already discussed ABL tree, so that in our next lecture we will discuss hash table. Yeah, so please read the book chapter, and then you from our previous based on our previous 3-4 lectures, we will have a quiz. Okay, and thank you so much, and you have a good day. Bye bye.